Hi everyone! In this video, I will talk about the basic concepts of recursion. You will learn two fundamental principles of designing recursive algorithms and three simple examples of solving problems recursively. Let's start with the definition of recursion. Recursion is a programming technique for performing a repetitive task. Its purpose is similar to a loop. How can a function execute a task multiple times without using a loop? It's by calling itself. When a function calls itself, at some point, it must know when to stop. Otherwise, it will keep calling itself indefinitely, leading to an infinite repetition which eventually causes the program to crash. There are two basic principles in designing a recursive algorithm. First, it must have at least one base case. What is a base case? A base case is a simple problem where we already know the answer to the questions we are trying to solve. The second principle is that every time a function calls itself, it must move towards the base case. In other words, every recursive call must reduce the complexity of the problem so that the problem eventually becomes very simple, where we know the solution. Let's see a classic example, the factorial function, which is defined as follows. For any positive integer, n factorial is the product of the integers from n to 1. By convention, 0 factorial is defined as 1. The factorial function is crucial because it represents the number of permutations of n items. For example, if we have three different things, A, B, and C, we can arrange them into a sequence in 6 different ways. A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. 6 is the result of 3 factorial. 3 times 2 times 1. To see how to calculate the factorial of a positive integer recursively, let's observe this example. 5 factorial is 5 times 4 times 3 times 2 times 1. When you observe this equation more closely, you'll notice that 4 times 3 times 2 times 1 is 4 factorial. And 3 times 2 times 1 is 3 factorial, and so on. Eventually, we reach 1 factorial, which can be calculated as 1 times 0 factorial. We know that by definition, 0 factorial is 1. Since we know the answer to 0 factorial, we can compute the result of 1 factorial, which gives us the answer to 2 factorial, all the way back to 5 factorial. We can generalize this observation by defining the factorial function recursively. For any positive integer n factorial is n times n minus 1 factorial, and 0 factorial is 1. Back to the basic principles of designing a recursive function, in general, it must have a simple case with the answer and a recursive case that moves towards the base case. Here, 0 factorial serves as a base case because by definition we know that 0 factorial is 1. The recursive case meets the requirements of producing a simpler problem because its recursive call is one step closer to the base case. When it reaches the base case, the function will stop calling itself and return 1, which eventually can solve the original problem. Implementing the recursive definition of the factorial function is straightforward. We define a function called factorial that takes n as an argument. If n equals 0, then return 1, else return n times factorial n minus 1. If you want to check that this function works correctly, please implement and test it. This exercise will improve your understanding of recursion. Let's take a look at another example, binary search. The binary search function takes a sorted sequence and a target value. This function returns true if the target value is in the given list or false otherwise. To design a recursive version of binary search, we need to think of the base cases and recursive cases. Recall that a base case is a simple case where the answer is known and that a recursive call must produce a simpler problem, moving closer to the base case. The basic idea of binary search is as follows. If the list is empty, return false because the target cannot exist in an empty list. If the middle element of the list equals the target value, return true because we find the target. If the target value is smaller than the mid value, we must search the target in the first half of the data. There is no point in exploring the second half of the list because their values are greater than or equal to the middle element. Remember that binary search requires a sorted list. On the other hand, if the target is larger than the mid value, we focus our search on the second half of the data. Here is an implementation of the binary search algorithm in Python. There are two base cases. If the data is empty, return false, and if the target is found, return true. There are also two recursive cases. The first one is when the target value is less than the mid element of the data, and the second one is when the target is greater than the mid value of the data. Notice that each recursive call passes a smaller list, half of the existing data. It means that each recursive call produces a simpler problem and moves closer to the base case. Now consider another problem of computing the sum of numbers in a list recursively. The simple case is that if the list is empty, we know the sum of an empty list is 0 because it doesn't have any numbers. If the list has one or more numbers, let's say if the list contains n elements, we can calculate the answer by adding the last number with the sum of the first n minus 1 numbers. You see the same pattern here that each recursive call produces a smaller problem. Initially, we want to sum n numbers, and the first recursive call reduces the problem into summing n minus 1 numbers. The next recursive call reduces the problem further into computing the sum of n minus 2 numbers, and so on until reaching the base case. In summary, this video reviews the basic concept of recursion. Recursion is an alternative way of performing a repetitive task. A recursive function calls itself to repeat the execution of a task. The task in each recursive call is typically getting simpler and simpler until it reaches the base case where the solution is readily available. We analyzed 3 recursive examples in which we implement the factorial function, the binary search, and the recursive sum function. Please try these examples and remember that learning by doing is a very effective way to learn programming and problem solving.